The best partners are expert learners. When one half faces a challenge, the other is right alongside, questioning, growing, and providing insights from the other's blind spots. And in today's case, the best partners are also experts in refrigeration. What exactly does the future of refrigerated storage design look like? And more importantly, who is making the design decisions that will shape it? That's on this episode of Beyond Engineering, a podcast from RTM Engineering Consultants. Hi, I'm Celine Dirks, your host for Beyond Engineering, where we share stories about innovative design, collaborative development, and exacting execution that helps buildings, businesses, and the people working inside them work better. Unless you're Kate Lyle, head of industrial cold and food at design services firm Ware Malcomb, or someone like her, you probably don't know what exactly designing a cold storage facility entails. You might guess that it requires refrigeration, but the challenges of designing and implementing those refrigeration systems present learning opportunities for both Ware Malcomb architects and the engineers they partner with. Luckily, RTM Principal Mike Best, who works with Kate frequently, is here to walk us through the lessons from a few of those challenges. Mike starts us off with a joke.
First, forgive the pun, but what makes working with cold storage so cool for you?
It's just so wonderful to work on really technical, complicated projects. I love diving into unique technologies. I love diving into different ways of looking about how we build buildings. I did speculative industrial for a long time, and those become very cookie cutter, right? There's always, we want to do it this way because it's going to be the most cost effective. This is how we're going to build the exterior. We're not worried a lot about air conditioning or that kind of thing. That is shifting nowadays. But with a cold storage building, you have to care so much about all of the little details, and you have to really think through unique ways because every building is so different. It has different needs. You're really thinking through things that are very, very technical and little puzzles that you're trying to put together. And that's just always been fun for me. I've always been a puzzle girl.
Can you give us some examples of some of these latest technologies?
The big change that's been coming in cold storage is a lot of additional verticality. So we're making a huge shift from buildings that are a lot of square footage to a lot of cubic footage. So we do cold storage buildings that are 140 feet tall. You're dealing with automated racking systems. So you have to know, how do you work with an automated system? What kind of electrical needs are you going to have? How are things charged? How are things structurally supported? What kind of refrigeration systems are going to work best for those kind of unique spaces? The great thing about refrigeration systems and why we go vertical is because you have a natural refrigeration cycle that is helping you out. So all that warm air is rising, the cool air is falling. And so you get even more of that the taller you go in the building. And so you're able to cool more product with less refrigeration, which is always great for the environment. Fire sprinkler systems change when you're dealing with that kind of height. You know, if you think about a 140 feet of freezer, you don't want the water to freeze by the time it gets to the floor. So you have to think very differently about how you get water if there is a fire event in one of these spaces. Dock design has changed significantly. We build significantly safer docks nowadays than even when I started doing cold storage 11 years ago. We do a lot more safety, interlocks, all of those kind of things to make sure that people are not getting injured in dock situations. So there's just all these little things that we keep on improving upon, and the technology keeps changing on. And there's always more to learn.
You mentioned automation.
Mm-hmm.
Does that reduce the need for people to be in these below freezing spaces?
Cold storage, of course, because it's not the nicest environment to have to work in, was an early adopter of automation. So we're seeing automation go across the industrial world nowadays, but cold storage was definitely at the forefront and continues to be at the forefront of utilizing automated systems.
Have you seen issues with installing automation in sub-freezing environments?
There's definitely different things you have to think about when you're dealing with automation in sub-freezing environments. You have to think about things like your slab design, right? A freezer floor is insulated, and so it's floating to a certain degree. And so the overturn on a very heavy, dense racking system is very different than if you can just bear on the ground a bit better. So there's all sorts of little things that we find that is unique to these cold storage buildings when integrating automation systems. Doors too, right? A lot of these systems have conveyance systems. They're moving through doors, but those doors might be between spaces that are at different temperatures. So we have to really think through door design and all of those conveyance doors in order to make sure that the different temperature zones are isolated and that we're not creating places where we're getting ice or water dripping or other things that can happen when you have two different temperature zones at these kind of temperatures competing against each other.
Now, cold storage is very energy intensive, so let's talk about the concept of sustainability. What does that mean for these types of projects?
Sustainability, when I started doing cold storage, the thought process then was, gosh, we're never going to get enough solar on this building to run this building, so why bother? It's wonderful to see that those attitudes have changed over the years. And now we still have the problem where it's hard to get enough power to a building generated on site, though there's some new technologies that are coming out for that. But there's definitely a philosophy of we might not be able to do everything, but we can do something. So there's a lot of companies that we work with that have ESG goals, that have all these requirements and are really trying to create more sustainable buildings. So ESG is environment, social, and governance requirements. So this is kind of a new standard that we're seeing across a lot of industries, a lot of businesses, where they're trying to set standards, not just for sustainability, but also for things like social equity. So making sure not just that you're designing green buildings, but that the people who are involved in those buildings are bringing a lot of diversity to the table. Governance is the way you run your business. So we want to make sure that we're working with companies that have wonderful ethical business practices. It's kind of a new standard. There's certain ways of measuring it that some companies have started to adopt. It's only a few years old, but it's certainly something that has taken off in the world as people try to find ways of being better businesses and measuring how they're doing in improving their practices. Also, the technologies have improved. When I first talked about doing solar on top of a cold storage roof, we didn't have ballasted solar systems. So that meant every little anchor had to go through my roof. And that was not great for my envelope because all those little anchors are little bits of metal that are transferring warm air from the outside to the inside, cold air from the inside to the outside. And so that was absolutely a no-go. We can't do that. We've now developed ballasted systems that we can do in most places where we can put solar on the roof without having to do an enormous amount of penetration. So the technology keeps on improving. We're seeing projects which are looking at cogen or other technologies where they're doing different types of on-site generation outside of solar because solar just takes up so much space, which we don't necessarily have in cold storage buildings, especially as we trade square footage for cubic footage. So as we go more vertical, our footprints get smaller and there's even less space for solar. It's great to see new technologies emerge.
Can you explain briefly what cogen is?
Yeah, cogeneration is a sustainable energy producing technology. And there's a lot of different ways that they can go about it, but the idea is that you're creating energy on site. There are a lot of different codes in the United States that we have to follow, but there's a lot of codes that are coming out that are green codes. So they're codes that are focused on sustainability. California Green Building Standards Code is one of the first ones that came out in the US, but we're seeing these coming out across the country. And certainly there are aspects of other codes like the electrical code that are incorporating some of these standards that are coming out of the green codes or LEED design standards or other types of sustainability standards that have been developed in the United States. So you can opt to have your building LEED certified, leadership in environment and energy design or something like that. And that certification means that your building is one of the most environmentally friendly buildings in the country.
And in the past, those codes and LEED did not necessarily apply to cold storage facilities. Is that correct?
Absolutely. LEED has always been a voluntary system, so it's certainly something that a lot of people thought was a great way to approach design, but it was never mandatory. So we started to see codes come out like the California Green Building Standards Code, which really brought those kind of same sustainable philosophies and made them mandatory. So having those designs be mandatory, it was challenging because obviously these are codes that are written for spaces that are not cold storage. So there are certain things always with the codes where we have to kind of say, look, I live in a different world here. Maybe this is not going to apply to my building. And so let's make sure that there are certain exceptions in place so that we can actually build our buildings, because we're not going to be able to do this.
We're subject to the rules of physics still.
Absolutely.
Now I'd like to ask you to get out your crystal ball. What do you see as far as the future in cold storage and food processing?
We keep on evolving, and the way we eat keeps on moving towards more fresh foods, more frozen foods, all of those kind of things. And so this is a huge supply chain issue because we need to create so many different spaces for all these different startup food companies. And oftentimes that's going into an existing warehouse and trying to take that existing warehouse and make it a food facility, converting what we call dry warehouse facilities or traditional warehouse facilities that weren't designed for food and cold storage. It creates unique challenges, but there's no other way to get the food to the people. So we're doing a lot more speculative buildings in the cold storage industry, which is really fascinating, to take something that has always been very built to suit and very specific to the end user and try to peel that back into something that can be flexible for a lot of different users.
Can you describe some of the challenges with speculative cold storage buildings?
Definitely. There's certainly challenges with temperature, right? Everyone has different temperature needs. If you're storing onions, it's very different than storing ice cream. So making sure that we're putting in refrigeration systems that have a certain amount of flexibility in the temperature ranges that they can utilize is very critical for doing speculative buildings. And oftentimes we're not catching those far ends of the spectrum, but the more we can know about the market, the more we can tailor those temperature ranges into what's most likely to be stored. So it might be a little bit warmer if we're seeing a lot of produce. It might be a little bit colder if we're seeing a lot of frozen food. Making sure that we can create demising walls in those buildings. It's important sometimes to separate different products, right? You don't want your meat sitting right next to your vegetables. So having ways to demise the spaces is really critical and challenging.
Some of the demising issues come when you have multiple tenants in a speculative building, right?
Absolutely. It can be really challenging because not only are you trying to keep the two tenants separated from a security standpoint and from a usage standpoint, but you're also having to deal with things like, oh gosh, I've got a really cold tenant here. I've got a really warm tenant here. We have to make sure that there isn't any thermal transfer and that we're not ending up with water on tenant A's floor because there's too much moisture coming from tenant B's refrigeration design too. It's not like an HVAC system where you have a lot of little units. A lot of times these refrigeration units are covering tens of thousands of square feet. So you have to think, okay, am I doing a design that's going to have lots of little spaces, which is more units, which is more costly, or am I doing a design that has fewer units but won't be able to be demised in the same way? If someone were to add a unit in the future, what would that look like? What would we have to do structurally? All these kind of things. They're also very, very heavy. So we have a lot more structural design surrounding the refrigeration units than we do with a lot of HVAC systems. It just compounds the challenges.
Wow, you architects have a lot of things to keep in mind, don't you?
Well, you engineers do too.
Speaking about the engineers, let's talk about how RTM supports your design work. What's the biggest challenge for refrigeration systems and design?
Really, it's the flexibility that we talked about, making sure that the refrigeration systems are going to work. Even if it's not a speculative building, you think about things like future proofing. Is this building always going to run at one temperature? Or in the future, would this building potentially need to change temperatures? And what would that look like? Refrigeration design is also very complicated because of that global warming potential, where we are really looking at changing what type of refrigerants that we use in the world. And so we're doing a lot of refrigeration conversions on buildings where you used to have Freon systems, and we're not supporting using those Freons anymore because they're too bad for the environment. So how do we change that? And what do we change it to? There's all of these different things that we need to think through in terms of what is the best type of refrigeration system for this particular project.
How about as far as mechanical design, the heating, ventilation, and air conditioning systems for these buildings? What challenges do you see there?
There's definitely challenges in terms of integrating those with refrigeration systems. We have spaces where we both have to do air changes through mechanical design and refrigeration in the same space, especially if we're doing processing or we have a lot of people in a space. So making sure those systems are integrated and not fighting each other is really critical. With food processing, there's a lot of cross-contamination issues that we deal with. And so we have to make sure that our systems are balanced and not creating breezes that are taking contaminants from one room to the other. So we have to really think about the pressurization of rooms.
How about electrical design? There must be a bunch of electrical requirements in a cold storage building.
There are so many electrical requirements. The electrical service sizes really get exponential in these buildings because you're dealing with refrigeration systems, which are very heavy electrical loads. But also, there's just so many things that you have to think about. Those automation systems are heavy electrical loads. You're having to make sure that you're providing power appropriately to all of your dock systems, all of those dock safety things and interlocks. That's all electrical design. All of your doors in a cold storage building, even if they're quote unquote manual doors, oftentimes have electrical power requirements because they have to be heated so they don't freeze shut. So there's all sorts of little things that we have to think about in terms of making sure that the power is distributed across the building, making sure that everything is designed well, choosing lighting fixtures that are going to work in washdown situations or in freezing temperatures or all of those kind of things. There's just so much complexity on the electrical side. Working with RTM is wonderful because I can come into it and say, these are the parameters that we're trying to work with. What would you recommend in terms of what the best refrigeration system is based on those parameters? And I can bring RTM into a discussion with the clients and really just have a partner who's able to present a lot of different systems. I try to be abreast of the broad generalizations as an architect focusing on this, but there's nothing like an expert. I'm not going to know every nuance of what the electrical loads are comparatively between refrigeration systems. Or I recently learned that, if you're making ice, you have to use different refrigeration systems than if you're not making ice and other things like that. So having the experts in there who can say, hey, actually, you can't use that system because you're trying to do this specific thing is really critical. What do you look for in partnering with architects? What can architects do better to work with the engineering team and make sure that we're working as a team together?
We really enjoy working with architects that know how buildings go together. It seems sometimes we get paired with architects that are very much into what things look like, but they're not necessarily easily buildable. And it is refreshing to work with an architect like Ware Malcomb, where everybody is very technical oriented. They know how things go together. They know how to detail things. So we don't waste a lot of time saying, did you think about this? This isn't going to work like that. I love going to meetings in person at Ware Malcomb because the people are always fun. They're happy. They're excited to see you and to dive into the project. We do a lot of our collaboration online through Teams meetings, but it's the in-person ones that are just a blast. We love working with Ware Malcomb because you guys know what you're doing and we don't feel like we're having to educate the architect. In fact, we learn a lot from you guys on all our projects.
Are you launching a career as an engineering technologist? Or are you a proven professional in the engineering fields looking for new ways to advance your career? Consider joining RTM Engineering Consultants. We support your growth as you sharpen technical skills, deepen business experience, and diversify capabilities across services, specialties, and markets from coast to coast. Our mentors are seasoned professionals committed to sharing expertise and passing knowledge from one generation of engineers to the next. Visit our careers page at rtmec.com to explore employment opportunities. That's rtmec.com. Learn why industry authorities consider RTM a great place to work, grow, and advance. Meantime, plan to join us again for another episode of Beyond Engineering, a podcast from RTM Engineering Consultants.